Okay, this is the 4.2 course practice physics quiz because apparently we need it for the periodic. A loop ABCD is rotating between the poles of a permanent magnet. Which of the following statements are true? So when you're rotating a loop, when you're rotating a loop through a magnetic field, so there's a force and you have B. So what's gonna be induced? A current, right? Which is true. When ABCD is horizontal, the rate of change of flux through the loop is 0. Okay, yeah. When it's horizontal, why I was a bit confused is because usually when we say when it's horizontal, it's maximum, right? But that depends on how the shape of the magnet is, right? Here, when it's horizontal, take a look. When it's horizontal, like here, the magnetic field goes like this. Isn't that perpendicular? Right? It's perpendicular. نحن شو اتفقنا? What did we agree on, guys? We agreed that when it's perpendicular, right? When it's perpendicular, the what do you call it? Induced EMF is 0 because d flux is equal to 0. The rate of change in flux when it's perpendicular is 0. Okay, and when it's parallel, but this is the sign for parallel, induced EMF is max. Okay, and in this case d flux over dt is max. Okay, because the rate of change in flux in this case is max. When ABCD is vertical, the current is 0. No, when it's vertical, ساعتها it's gonna be straight up like this. Okay, right. Oh, that's disgusting. Let me redraw that. هيك okay, هيك بيكون شكلها, and the magnetic field will be done this, so like this, they're parallel to each other, and that's when it's maximum, right? So would it be 0 in that case? No. The current generated in ABCD is alternating. Of course it's alternating because you're looping. The current through the galvanometer changes direction twice every complete rotation. Of course, right? Every complete rotation is 360 degrees, right? نحن اتفقنا it changes direction when every half rotation, right? Every half rotation it changes. Okay, once. Okay, so أكيد every full rotation then it's going to change twice. The frequency of the current is double the frequency of the loop's rotation. Why? There's no point. No, there's no reason. It's the same. Okay, the frequency is the same. Question 2. Okay, there's two different methods of generating electricity and they're illustrated below. Which one's alternating? Which one is one direction only? Okay, obviously A is alternating current and B is DC, direct current. Okay, how can you know? Because here you have أول شيء you have the slip rings commutators. These are used for AC, okay? And they're fixed, as you can see here. Okay, it keeps on changing direction. But here in DC, it's the same direction. So the positive is here, the negative is going to be here. If you're looking at alternating current, there's no positive or negative side. Okay, so when you have two rings like this is AC, and when you have one ring like this and one split ring, it's called the split ring commutator here, it's called DC, right? Direct current. Okay, a coil is rotated in the presence of an external magnetic field to produce electricity. When is the surface of the coil perpendicular to the magnetic field? When it's perpendicular, يعني شو 0, right? When here and here. Okay, when is the surface parallel to the magnetic field? When is it parallel to the magnetic field? Okay, parallel يعني max. When is it max? At B and also D. Please don't say this is the minimum, okay? It's just called the negative maximum, okay? That's what it's called, the negative maximum, okay? So B and D. So is this also considered maximum? Yes, but just in the other direction, and that's completely fine, okay? So if you see a question like this, please also consider the one in the negative sense. Part 4, question 4. Which of the following statements are true about the AC generator? Okay, the current is removed via a twin ring commutator. Yes, we have two, right? In the simple generator, the magnet rotates about a stationary coil? No. The magnet is the one that rotates? No. We move the coil around the magnet, right? An AC generator can contain either a permanent magnet or an electromagnet. Of course, yeah, why not? They both induce magnetic fields. An AC generator can contain either slip ring or split ring commutator. No, اتفقنا an AC generator can contain slip rings. DC is the one with split ring commutators. If the loop of the generator moves uniformly, the current generated varies according to a sine function. Yes, we know that the current is sinusoidal, right? So it looks like this, right? Okay, and what was it, by the way? I don't know if it was in this chapter. Let me check. Yes, and Bella, it is in this chapter. I max sine 2 pi f t. Let me go to the quiz and write it for you. Okay, the sine function, what is this? The sine function, I is equal to I max sine 2 pi f t. Okay, so مثلا sometimes they ask you to find the frequency, and they give you the time, and they give you I max. Okay, like they give you the function, they ask you to find I max and frequency. You need to know this rule. Okay, I max will always be the number here, and the frequency you just divide by 2 pi. I think it was 2 pi ft, صح? Yeah. Okay. You need to know that it's what? Sinusoidal. If they said cosine function, it's wrong. Okay, it just has to be sine. Okay. طيب. Question 5. Calculate the p. Okay, yeah. See, this is the question. I is equal to 45 milliampere sine 18.8 rad per second times t. Okay, use pi is equal to 3.14. How do you find I max? It's always the number here. So they gave us milliampere, so you don't need to change the unit. It's directly just 45. How do you find frequency? This, I told you, this is 2 pi ft. Here they gave you the t or second, so these two cancel. Okay, so we finished, we cancelled the t. خلاص. We cancel the t because they gave you t, as you can see, huh? So 2 pi ft, if you cancel, okay. We want to find frequency. Okay, we know this is equal to 18.8. So how do you find frequency? You just divide by 2 pi. So we're just going to do 18.8 divided by 2 pi. So 2 times 3.14. You get to 2.99 or 3, right? So you can just round it to 3. Here it's two significant figures, so I'll make it 3.0 if you want. Type. So if you see a question like this in the exam, what do? You just divide this by 2 pi. Okay. Question 6. The peak current in the AC current is 20 milliampere. What is the RMS current? Okay, I RMS, remember, is equal to I max over radical 2. So it's going to be 20 divided by radical 2. So you're going to get, let's take a look, 20 divided by root 2. It's going to be 14.14. To one decimal place, 14.1. This is the material, huh? Yeah, 4.2.3. Man, this stuff, okay, see this stuff here, it's not in the material. So مثلا this is correct عادي. Okay, and I'm just solving it all, but for the periodic, this isn't required. This is required. What's this? Is this here? لا, it's not required. Okay, for DC AC you need to know them. خلاص, just know them all. صراحة they're all pretty easy. Calculate the peak value. Okay, this stuff, calculations, you don't need them. 5, 6, you don't know them. This you need it. خلاص, we'll do them all. I'm gonna do them all anyways, because I'm recording for finals. Anyways, question 7. Select the graph. I think maybe it's only 3 questions that aren't needed. But do you need oscilloscope? Because oscilloscope's annoying. Let me see. Is oscilloscope needed? Please say no. Oh, it is. Okay. Consider the device shown below. Select the graph that describes the current output of this device. Okay, this is obviously DC, right? This is DC. So is it going to be this? No. Well, it's not going to be this. Is it going to be this? You know, what should stopped? Okay, no. Does DC stay at maximum? No. DC is always changing, but it doesn't go down into the negative sense. So it just keeps on going like this. This comes in the exam. In the exam, they asked for alternating current. Alternating current is just this. Okay? Sinusoidal. Type. Question 8. A bar magnet is attached to a vertical spring as shown below. The spring is pulled up, compressed, and then released. The coil is attached to a sensitive galvanometer. Okay. When is the current in the circuit instantaneously 0? Let's see. When the spring reaches its greatest length and smallest length. You should know that when the spring reaches its greatest length, based off of our mechanics knowledge, V is equal to 0. And also when it's at the smallest length, V is equal to 0. Right? Okay, that means no motion. Right? That means there's no force. That means if you do FBI, Is there gonna be an F to get an I? No. Okay, so when is it 0? When these two, okay? Part B, when the magnet leaves the coil on its way up, the direction of current is from point B to point A. Let's see. So this, you need to use Lenz's law for this. It's probably not going to come in our periodic, but for finals, when the magnet leaves the coil on the way up. So on its way up, let's see. When the magnet, so the force is up. So نحن we know it's gonna oppose. فit goes down, right? It opposes. طب okay, if it's going down, rotate your fingers, point your thumb downwards. Okay, okay, and your fingers. How do I draw this? Your fingers are gonna look like, I don't know, like this. Four fingers. Okay, and this is your hand, right? Okay. Top curl them. Okay, if your thumb is pointing downwards, okay, coil your fingers. How's it gonna look? It's gonna look like it's going from. It's gonna go like this, and it's gonna go like this, right? It's gonna go in that direction if you curl your fingers. Okay. So when you do that, that means our current is going like this. But let's see. Does that mean it's starting from A? Okay, here it's going like this. That's opposite to what we're doing. So that means, let's see, how about if you started from B, go to B. Isn't that the same thing? Yeah, so we're starting at B, going to A. That's how you do it. Okay. Which device uses the effect studied in this experiment? A dynamo. So this is the principle of the dynamo. So he could get it if he wants, because that's how it works. Okay, it's a spring that uses this principle. Okay, you can read it if you want. That's basically, you have a magnet and then you have a coil, whatever, what keeps on rotating and produces energy. La 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 la. Rap. Yep. Okay, question 9. In which of the following devices does the current change its sense? Twin ring, akid, yes. Slip ring, yes. Okay. Slip rings is the one the AC uses, huh? Split ring, no. Split ring, هيدي DC. Okay. Simple dynamo, akid, it's correct. We said simple dynamo uses the principle of AC, huh? Read it if you want. The bicycle, I'll read it and explain it. Okay, by the way, this page is fully optional. It says it here. This is optional material if you want to know. But here, basically, you need to know that the dynamo, it's the same thing. عندك الcoil, here, this is the coil, عندك soft iron core, عندك magnet, okay, which just keeps on producing energy on the bicycle tire. Okay, same thing. You need to know it's an alternating current. Okay, advantage, if they ask us, I doubt, really. The advantage is that it doesn't wear out. Okay, so it doesn't wear out. Okay, anyways, but these are the three that use AC. Question 10. كمان I think oscilloscope uses AC, صح? Yeah, oscilloscope uses AC. Okay, but no, it can be DC also. It doesn't necessarily have to be. We'll get to oscilloscope. Okay, transcranial magnetic stimulation (TMS) is a medical technique aimed at treating anxiety and depression. Both conditions are known to arise from the abnormalities in currents flowing between the nerve cells in the brain. During the TMS procedure, a patient wears a helmet that contains current-carrying coils. The currents in these coils is rapidly changing. The current-carrying coils generate a variable magnetic field. Type, okay. Let's see here. When you have a rapidly changing current, okay, it creates a variable magnetic field, right? When you have a variable magnetic field, everything's changing, it causes an eddy current. Okay, so you need to know what happens in TMS. Basically, eddy currents occur. Eddy currents are these abnormal spikes in current. Okay, we don't like them. We don't like eddy currents. Okay, anyways, you need to know what happens when you have a rapidly changing current. There's a variable magnetic field, okay, and therefore causes the eddy currents. Which of the following can change the maximum current generated in the brain? Okay, let's see here. The frequency of the current oscillation. Akid, if there's a higher frequency of current oscillation, then there's going to be more maximum current, right? The magnitude of the RMS current. Akid, isn't maximum current, isn't IRMS Imax over root 2. So if you change IRMS, Imax will also increase, right? The proximity of the helmet to the scalp, akid, how far the helmet is to the scalp. If the helmet is very far, then it will be smaller. If you get it closer, then it will be better. The ambient temperature, no. The duration, no. Why would that adjust? We never spoke about time. Question 11. A single conducting loop is rotating in a magnetic field at a constant frequency. The expression is this. The RMS current is how much, and the frequency of the current oscillations is... Yeah, if a single conducting loop is rotating in a magnetic field at a constant frequency, the expression is this. What is the RMS current? Okay, how do you find RMS? It's just I max over root 2, right? For what's I max here? 14.1. For 14.1 اقسمها على root 2. You're gonna get how much? Let's see, 14.1 divided by root 2. 9.2, the nearest whole number, 10. Okay, the frequency of the current is how much? How do you find frequency? I always tell you divide this number by 2 pi. Okay, divided by 2 pi, you should get 8. Without a calculator, you can do it, huh? Okay, so you're gonna get 8. Question 12. 14 questions, I think. The diagram below shows the EMF induced in a loop rotating in a magnetic field. At t equals 0, the surface of the loop is parallel to the magnetic field. Let's take a look. At t equals 0, we have the maximum EMF, right? So أكيد it's going to be parallel. And at 15, it's 0. فأكيد it's going to be perpendicular, right? And اتفقنا when it's parallel, it's maximum. When it's perpendicular, it's 0. If the resistance of the loop is 0.08, then the RMS value of the current to the loop to the nearest integer is what? Let's take a look. Okay, first thing you need to know is here you have volts, not current. Okay, so you can't find current from the graph. Okay, but they give us resistance, and we know we can relate resistance, voltage, and current, right? We know R is equal to V over I, or other people say V equals Ri, whatever, but I is going to be equal to V over R, right? So the voltage, we know to find the value of current, you need to do I max divided by root 2. صح؟ طب let's find I max by doing V divided by R. So you take V max, which is 10, divided by the resistance, 0.08. Let's do it. 10 divided by 0.08, you're gonna get 125. Okay, if I is gonna be equal to 125 milliampere. This is the maximum value. And please consider that we're solving in milli. Okay, I took the voltage as milli. I didn't bother changing the unit because I kept it as milli, because here they also want milli in the answer. So I didn't change any units. Okay, and then how do I find the RMS? I just divide this now by what? By radical 2, and you get 88. خلاص ما بدها لا. Question 13. Arrange the steps describing the functioning of an induction cooker. Label the first step 1. Okay, an induction cooker, I think, is just the electrical cooker, electric gas. Okay, an alternating current is passed through the coil, obviously, which generates an alternating magnetic field. Okay, the magnetic field generates eddy currents, and this eddy currents cause the pot to heat up. Memorize this. Okay, it's not that hard. It's basic common sense. If you turn on an oven, how does it work? Okay, the diagram below shows the screen of an oscilloscope. The student has measured the peak value to be 6 millivolts. Okay, so this they measured this to be 6.0 millivolts, and it takes the electron 0.10 seconds to cross the screen. Okay, this is to cross the whole screen is 0.10 seconds. So all of this is apparently 0.10 seconds. Okay, the vertical sensitivity of the oscilloscope is how much? Let's see. Some people, what they do is they do this. Look, they do this for the vertical sensitivity. They count 6 squares, يعني 6 divided by 6, and they put 1 and they got it wrong. Why? Why is this wrong? ما انت حبيبي, you have to do this. Look, you have to start. When is zero تبعك? Your zero is halfway through. So this is how it should be. Okay, you count 3 squares. Okay, instead of 6. Okay, man, this should be your 0, صح? Okay, so 6 divided by 3 and you get 2. The horizontal sensitivity of the oscilloscope is how much? Again, نحن اتفقنا the whole thing is 0.10 seconds. Okay, but they want it in milliseconds. So let's first convert this to milliseconds. Multiplying by 1000 will get you 100 milliseconds. Horizontally, how many squares do we have? We have 20 squares if you count them. Okay, so 100 now divided by 20 will get you 5 milliseconds. Okay, there are 6.7 horizontal divisions in one complete cycle of the signal. Okay, over here, from here to here, it's 6.7 divisions, right? One complete cycle. The frequency of the signal to the nearest integer is something. Okay, to find the frequency, well, this kind of looks like a wave, right? You deal with it as a wave. Frequency is equal to, now we don't have anything other than time. What's the only thing that relates frequency to time? 1 over 2, 1 over t. Okay, when they gave us how many divisions are in one complete cycle of the signal. Okay, طب نحن we know each division is 5 milliseconds. So if I have 6.7 divisions, Can I find out how much the time is for one complete cycle, which is basically the period? Yes, of course I can. Okay, so for one cycle, it's 6.7 divisions. Okay, and each division is a day, it's 5 milliseconds. فشو بتعمل 5 times 6.7. Okay, 5 times 6.7 you get 33.5, right? طيب, this is your what? This is your period. Okay, this is your period in what? Milliseconds. طب I want frequency. Isn't frequency equal to 1 over t? Okay, but t in this case has to be seconds. Let's change this to seconds before we do anything else. Let's divide it by 1000. Okay, you're gonna get 0.0335. Okay, so t is equal to 0.0335. How do I find frequency? It's a 1 over t. So 1 over 0.0335. Okay, so 1 divided by answer 29.8 to the nearest integer is gonna be 30. Thank you so much for watching, and good luck. Okay.